take a deep breath in, drawing the air down into the very base of your lungs. And as you exhale, feel the weight of your body beginning to settle. Let your shoulders drop away from your ears. Release the tension in your jaw. Imagine a soft, heavy blanket of stillness being drawn over you, limb by limb. With every breath you take, you are becoming more attuned to the rhythm of the universe. A slow, patient pulse that beats across the vast distances of space. In your mind's eye, I want you to step away from the familiar world. Feel the boundaries of your room dissolve as we begin a journey far beyond the reach of our own sun's warmth. We are traveling nearly 1 billion miles away toward the outer reaches of our solar system, to a world that feels like a dream of Earth held in a deep, crystalline freeze. This is Titan, the largest moon of Saturn. It is a place of profound silence and ancient, slow-moving beauty. As we arrive, the first thing you notice is a sense of incredible lightness. On Titan, the gravity is remarkably low, only about 14% of what you feel on Earth. If you were to take a step, you would feel as though you were moving through a gentle, supportive medium, almost like being underwater, but without the resistance. Your movements are slow, fluid, and effortless. Your heart rate slows to match this leisurely pace. The air here is thick and comforting. Most people don't realize that Titan is the only moon in our solar system with a substantial atmosphere. In fact, the atmospheric pressure at the surface is about 50% higher than Earth's. It feels like a gentle, firm embrace against your skin, a physical weight that grounds you even as the low gravity makes you feel buoyant. This dense air is composed of 95% nitrogen, much like the air you breathe at home, but here it is infused with a rich, complex chemistry that creates a world unlike any other. Look up at the sky. There is no bright, piercing sun here. Instead, the heavens are draped in a permanent, luminous haze of deep tangerine and soft gold. This beautiful glow is caused by a phenomenon called tholins. These are complex organic molecules formed when sunlight strikes the methane high in the atmosphere, creating a gentle rain of organic soot that drifts down through the sky like microscopic golden dust. It scatters the light so perfectly that there are no harsh shadows, only a soft, diffused radiance that bathes the landscape in a warm, eternal twilight. The temperature here is a constant, profound chill, roughly -179 degrees Celsius. While that sounds extreme, in this world of quiet observation, it manifests as a total absence of heat-driven chaos. There is no frantic buzzing of insects, no scorching heat of the sun. Everything is preserved in a state of perfect, frigid clarity. The cold is a structural force here. It has turned water, the very substance of our oceans, into a rock so hard and durable that it forms the bedrock and the mountains of this moon. As you begin to walk across the surface, listen to the sound of your footsteps. Because the atmosphere is so much denser than Earth's, sound travels differently here. It is more resonant, yet more muffled, as if the air itself is a thick velvet curtain. You hear a low, rhythmic crunch beneath your feet. You aren't walking on silica sand, but on grains of water ice and solid hydrocarbons, rounded over eons by the flow of liquid methane. Look down at the ground. You might expect to see jagged rocks, but instead, the landscape is dotted with smooth, rounded pebbles. What is fascinating is that these pebbles are actually made of frozen water. On Titan, water plays the role of rock, and liquid methane plays the role of water. These river rocks were shaped by ancient flows, that tumbled over centuries until their edges became as soft and smooth as a worry stone held in the palm of your hand. Feel the texture of one in your mind, cold, incredibly solid, and polished to a matte finish by the slow passage of time. There is a scent in the air here, too, something most would never expect. It doesn't smell like the vacuum of space. Because of the complex hydrocarbons, the air carries a faint, sweet, and heavy aroma. It's reminiscent of the scent of a clean, distant workshop, or the faint, earthy smell of bitumen after a soft rain. It is a rich, organic perfume that speaks of the moon's complex chemistry, a precursor to the building blocks of life itself, held in a deep freeze laboratory of nature's own making. You are moving toward the shore of one of Titan's great northern seas, Ligia Mare. As you approach, you notice the wind. It is not a biting gale, but a slow, thick movement of the atmosphere. Because the air is so heavy, even a light breeze carries a physical presence, like the slow movement of a deep-sea current. It moves the orange haze in long, lazy ribbons, revealing glimpses of the horizon. On Titan, the seasons are long and patient. It takes Saturn nearly 30 Earth years to orbit the Sun, meaning each season on this moon lasts for over 7 years. There is no rush here. The environment operates on a timescale that invites you to let go of your own sense of urgency. The methanological cycle, here the way methane evaporates into clouds and falls as rain happens with a rhythmic, seasonal grace that makes the rising and falling of our own tides seem frantic by comparison. As you reach the edge of the liquid, you see the surface of Ligia Mare. It is not blue like the oceans of Earth. It is the color of dark, clear honey or a deep, liquid obsidian. The liquid is a mixture of methane and ethane. And because these fluids are less dense than water, they are incredibly still. What's truly remarkable is the smoothness of this sea. On Earth, the wind constantly whips the ocean into whitecaps and swells. But here, the waves are rarely more than a single centimeter high. The surface is a perfect dark mirror, reflecting the orange glow of the sky with such clarity that it's hard to tell where the shore ends and the water begins. It is a level of stillness that is almost impossible to find on our home planet, a vast, liquid expanse of perfect, unruffled peace. Find a place to sit on the shore, perhaps leaning against a smooth outcropping of water ice. The ground beneath you is stable and ancient. As you settle in, you realize that even though this world is billions of miles away, it feels deeply familiar. It has clouds, it has rain, it has rivers and seas. It is a twin of Earth, but rendered in a different palette of elements. A quiet, frozen cousin to our own vibrant world. You watch as a few magic islands appear and disappear in the distance of the lake. These aren't actual land masses, but clusters of nitrogen bubbles rising from the depths, shimmering on the surface for a few moments before dissolving back into the dark liquid. It is a gentle, bubbling process, like the Earth itself is breathing in its sleep. The atmosphere around you feels thicker now, more protective. You are safely cocooned in this world of orange light and obsidian waters. There is no sound here, except for the very faint, low-frequency hum of the atmosphere moving through the icy valleys behind you. A sound so deep and resonant, it feels more like a vibration in your chest than a noise in your ears. As you sit here, by the edge of this alien sea, you feel a profound sense of connection to the cosmos. You are witnessing the slow, majestic processes of a world that doesn't need heat or light to be beautiful. It exists in its own time, governed by its own gentle laws of physics. The low gravity makes your body feel as though it is floating. Even as you sit, your breath slows down, matching the 7-year rhythm of the Titanian seasons. There is nothing you need to do. There is nowhere you need to be. You are simply a quiet observer of the methane lakes, a guest in this cathedral of ice and orange mist. In the distance, you can see the faint, hulking silhouette of Saturn hanging in the sky, obscured by the thick haze. It is a massive, silent guardian, its rings casting a subtle influence over the tides of this moon. The scale of it is breathtaking, yet it doesn't feel overwhelming. It feels like part of a grand, orderly design, a clockwork of planets and moons, all moving in perfect, silent harmony. The sand beneath your hands is cool and dry. It's made of organic solids that have settled from the sky over millions of years. Each grain is a tiny piece of a puzzle, a molecule that could, in another place and another time, have been part of a living cell. Here, they rest in a state of quiet potential, waiting in the cold. As the orange twilight deepens, the world becomes even stiller. The tiny, centimeter-high ripples on the lake's surface catch the last of the diffused sunlight, glowing like liquid copper. You feel a deep, satisfying sense of rest. The weight of your day, the worries of your world, they have all been left behind, filtered out by the thick nitrogen atmosphere and the vast distance of space. You are now fully immersed in the environment of Titan. You have become part of its stillness. The air is heavy, the gravity is light, and the world is a masterpiece of dark liquids and golden mists. You are ready now to explore deeper into the hidden rhythms of this moon, to see how the methane flows and how the ice mountains stand watch over the obsidian seas. But for now, just breathe. Breathe in the cool, still air of this distant world, and let the silence of Titan fill you with a sense of eternal, unshakable peace. You are settled. You are safe. You are home in the stars. Notice how the silence of this world seems to deepen as we move further inland, away from the quiet lapping of the methane shoreline. We are walking across a plain of organic silt, a landscape that remained a total mystery to humanity for centuries. Consider the year 1655. A Dutch astronomer named Christian Huygens pointed his handmade telescope toward the ringed planet Saturn and noticed a tiny, persistent dot of light. He had discovered Titan, but for the next 350 years, this world remained a blurred, orange smudge in our lenses. Because of that thick, opaque atmosphere we felt earlier, no one knew if Titan held solid ground, a global ocean, or nothing but clouds. It wasn't until the Cassini-Huygens mission arrived in 2004 that the veil was finally lifted. What's striking is how the discovery of these lakes actually happened. Scientists used radar to pierce through the haze, much like a bat uses echolocation to find its way through a dark cave. In 2006, the Cassini spacecraft sent radio waves down to the surface. When the waves hit the liquid, they didn't scatter. They reflected back with a perfect, mirror-like intensity. This revealed the existence of Kraken Mare, a body of liquid so enormous it covers about 400,000 square kilometers. To give you a sense of its scale, that is larger than the Caspian Sea on Earth. Picture a body of liquid that stretches for hundreds of miles in every direction, yet remains as smooth and undisturbed as a sheet of black glass. At this very moment, imagine we are standing on the damp, dark soil of the shoreline. When the Huygens probe actually touched down on Titan in January 2005, its sensors recorded something scientists hadn't expected. As the metallic feet of the lander met the surface, the instruments felt a splat, a specific resistance that suggested the ground had the consistency of wet sand or perhaps a firm, cold crème brûlée. This is because the surface is saturated with liquid hydrocarbons. The ground isn't dry dirt, it's a chilled, organic sponge, damp with the same chemicals that fill the lakes. Feel that texture in your mind, a soft, yielding crunch that holds its shape, like walking on packed, frozen snow that has been dusted with fine cocoa powder. Deep within the liquid of l'Egea Mare, the second largest sea, there is a clarity that is almost impossible to imagine. Scientists discovered that this sea is about 160 meters deep in its center. That's roughly 525 feet of liquid methane. What's truly unusual is that the liquid is so pure and transparent that Cassini's radar was able to pass all the way through the sea, bounce off the bottom, and return to the spacecraft. If you were to dive into these depths, the liquid would feel remarkably light, about half as dense as water, and it would be so clear that you could see the hills and valleys of the frozen water ice seabed far below you, illuminated by that soft, golden atmospheric glow. Notice the way the chemistry here creates a unique sensory palette. The liquid in these lakes isn't just one thing. It is a mixture of roughly 75% methane, 25% ethane, and a small amount of dissolved nitrogen. Because ethane is slightly heavier and has a higher boiling point than methane, it tends to accumulate in the deeper basins. This creates a subtle layering within the sea, a slow-motion blending of fluids that happens over centuries. There are no fast currents here, no churning tides. The liquid moves with the weight of cold honey, a viscous and patient flow that shapes the coastline with the gentlest of touches. Scientists have observed something curious about the geography of these lakes. They are almost entirely clustered in the northern hemisphere. Only a few small, scattered ponds exist in the south, such as Ontario Lacus, which is roughly the same size and shape as Lake Ontario on the border of the United States and Canada. This hemispheric imbalance is likely caused by the long, eccentric orbit of Saturn around the Sun. Over cycles of tens of thousands of years, the intensity of the seasons shifts, causing the liquid to slowly migrate from one pole to the other through the atmosphere. It is a planetary scale migration, a slow breathing of the moon's resources that takes millennia to complete. Imagine the patience of a world where a single tide takes 10,000 years to move across the globe. What's happening now beneath our feet is a process of replenishment. One of the most significant facts about Titan is that its methane is constantly being destroyed. High in the atmosphere, ultraviolet light from the distant sun breaks methane molecules apart, turning them into the heavy tholins that create the orange haze. Scientists have calculated that without a way to replace it, all the methane on Titan would vanish in just 10 million years, a blink of an eye in cosmic time. This means there must be a hidden reservoir of methane deep within the moon, likely in the form of clathrates, or methane ice, that slowly outgasses into the air. The lakes are not just static pools. They are the visible part of a deep interior heartbeat, a cycle of gas and liquid that has persisted for billions of years. Picture the empty lake beds that Cassini discovered near the poles. These are vast, flat basins surrounded by steep walls, sometimes hundreds of feet high, but they contain no liquid. They are essentially paleo lakes, ghosts of a time when the methane levels were higher. These basins are coated in a thick layer of evaporites, which are the solid organic minerals left behind when the liquid methane vanishes. On Earth, we have salt flats. On Titan, we have hydrocarbon flats. They are incredibly smooth and reflect the light with a soft, matte sheen, like a desert made of finely ground graphite or slate. As we continue our stroll along the margin of the sea, consider the incredible distance this moon sits from the center of our solar system. Titan is approximately 1.4 billion kilometers from the Sunday. At this distance, the Sun appears as little more than a very bright star in the sky, providing only about 1% of the light we receive on Earth. This distance is what allows the methane to remain liquid. If Titan were just a little closer, the heat would turn these seas into gas a little further, and they might freeze solid. It exists in a perfect cold equilibrium, a Goldilocks zone for an entirely different kind of chemistry. Think about the time it takes for anything to happen here. When the Huygens probe descended toward the surface in 2005, it took 2.5 hours to drift down through the thick atmosphere. During that 90-minute descent, the probe swung gently under its parachute, recording the sounds of the wind. It was a low, rushing sound, a heavy atmosphere moving against a metal hull. That wind is what shapes the dunes we see in the distance. These dunes are not made of silicate sand, but of plastic grains, complex organic solids that have been blown into long, linear ridges by the steady, thick winds. Some of these dunes are over 100 meters high and stretch for hundreds of kilometers, following the equator like the ripples on a giant, dark fingerprint. There is a profound stillness in the realization that we are the first generation of humans to even know these lakes exist. For the vast majority of human history, Titan was just a point of light, a silent witness to our development. Now, we can map its coastlines, measure its depths, and understand its rains. We have learned that Titan is the only other place in the known universe where stable liquid exists on the surface, making it a mirror of Earth, reflected in a much colder glass. Invite your focus to rest on the shore once more. The pebbles here, which we mentioned, are made of water ice, are sorted by size. Just as a river on Earth organizes rocks, the methane rivers of Titan have moved these ice stones during rare, heavy rainfalls. Every few decades, a massive methane storm will drench the landscape, sending flash floods through the carved canyons and out into the seas. These events are rare and peaceful in their rarity. They are the pulses of life for the moon, a sudden influx of liquid that refreshes the lakes and cleanses the riverbeds. Between these storms, the moon returns to its state of perfect, orange-tinted quiet. The liquid methane in the lake sits motionless, its surface tension so high and the gravity so low that it resists the wind. It is a world that has mastered the art of waiting. The mountains of ice stand as eternal sentinels, the dunes migrate with glacial slowness, and the seas reflect the hazy sky with an unwavering, obsidian stare. You are standing in a place where time has a different meaning, where the cycles of nature are measured in decades and millennia rather than days and hours. Permit this sense of vast, slow time to settle into your own heart. There is no rush. There is only the steady, cold, and beautiful reality of this distant moon, humming with the quiet music of its own unique existence. We are ready now to look closer, to see how the very molecules of this world interact in the deep chill, creating a landscape that is both alien and deeply, resonantly peaceful. Observe the sky once more, where the tangerine clouds hang heavy and low. If you were to wait here long enough, you would witness a rainstorm unlike any experienced on our home planet. Imagine the clouds overhead beginning to release their cargo. On Earth, raindrops are small, frantic things, zipping through the air at roughly 9 meters per second. But on Titan, the physics of the world transforms a rainstorm into a ballet. Because the gravity is so weak, only 1/7 of Earth's, and the air is so thick, the methane raindrops grow to a staggering size, reaching up to 9 millimeters in diameter. Picture a raindrop the size of a large marble. What's truly extraordinary is the speed at which they travel. These heavy, translucent spheres drift toward the ground at only 1.6 meters per second. This is a pace slower than a person walking. It is as if the clouds are gently releasing millions of slow-motion feathers made of liquid gas, which drift downward with a rhythmic, mesmerizing grace. As these drops meet the surface, they don't strike with a splash, but rather merge softly with the existing pools. Think of the way a heavy bead of oil moves when it touches a cold pan. There is a momentary hesitation, a soft ripple, and then total integration. This methane rain feeds the river systems that scientists have mapped across the moon's northern reaches. Consider Vid Flumina, a river system that flows into the Ligeia Mare. This river is over 400 kilometers long, branching out across the landscape like the intricate veins on the back of a leaf. What is noteworthy here is that these rivers have carved deep, steep-walled canyons into the water ice bedrock. In some places, these canyons are over 500 meters deep with slopes steeper than 40 degrees. Imagine the Grand Canyon, but instead of red desert rock, the walls are made of dark, diamond-hard ice, and the river flowing at the bottom is a silent, freezing stream of liquid natural gas. At this very moment, try to visualize the buoyancy of this world. On Earth, we are used to the idea that ice floats. If you put an ice cube in a glass of water, it bobs on the surface because water expands as it freezes. However, on Titan, the rules of the kitchen are reversed. If a chunk of solid methane were to form and fall into a lake of liquid methane, it would sink straight to the bottom like a stone. This is because solid methane is denser than its liquid form. Picture a lake bed where the floor is littered with ice that never rises, creating a submerged landscape of frozen methane blocks. This creates a unique layering in the seas, where the coldest, most solid parts of the world are tucked away in the deep, dark trenches, far beneath the surface. Notice the physical sensation of the air around you. The atmospheric pressure here is about 145 kilopascals, which is roughly 1.5 times higher than the pressure at sea level on Earth. To understand how this feels, imagine you are at the bottom of a swimming pool, about 5 meters deep. You can feel a slight, firm pressure against your eardrums and your skin, a sensation of being fully submerged in a medium that supports you. This high pressure, combined with the cold, means that the air is 4 times denser than Earth's air. If you were to attach wings to your arms, the air is so thick and the gravity so low that you could easily soar through the sky just by flapping your hands. You would move through the nitrogen haze with the effortless glide of a manta ray moving through the ocean. Scientists discovered something quite unusual about the way light interacts with these lakes. Because the sun is nearly 1 billion miles away, the total amount of light reaching Titan is about 1,000th of what we receive on Earth. To your eyes, the brightest day on Titan would look like a very dim room or the deep twilight just after the sun has slipped below the horizon. What's interesting is that this dim light is almost entirely in the red and infrared spectrum. Blue light is scattered away by the thick haze long before it reaches the ground. This means the world is a monochromatic masterpiece of copper, gold, and deep mahogany. It is a visual environment that demands your eyes relax. There are no harsh glares, no neon colors, only a soft, sepia-toned world that feels like an old, cherished photograph. Picture the edges of the lake where the liquid meets the shore. In many of these basins, there are visible rings of bright material surrounding the dark liquid. These are known as evaporites. Think of the white, crusty ring left behind in a bathtub after the water has drained away. On Titan, as the methane and ethane slowly evaporate into the atmosphere during the long summer, they leave behind dissolved organic solids like acetylene and butane. These solids form a pale, powdery beach that crumbles underfoot. It's a literal desert of organic chemicals, a shoreline made of the same materials we use on Earth as fuels. But here they are just quiet, inert minerals, glittering softly in the dim light. What's happening now deep beneath the surface of the moon is perhaps the most incredible secret of all. While we are focusing on the methane lakes, scientists have used gravity measurements from the Cassini spacecraft to determine that Titan likely hides a massive, global ocean of liquid water, about 100 kilometers beneath its icy crust. This interior ocean is estimated to be extremely salty, perhaps as salty as the Dead Sea. Imagine the moon as a giant, cosmic jawbreaker, a core of rock, a massive hidden layer of salty liquid water, a thick shell of water ice, and finally, the surface we are standing on with its methane seas. You are resting on a multi-layered world, a complex structure of hidden depths and surface beauties, all held together in a cold, silent balance. Consider the magic islands that have puzzled astronomers for years. In radar images of Ligea Mare, bright spots occasionally appear in the middle of the sea, only to vanish a few months later. Scientists have proposed that these are not land masses at all, but rather large clusters of nitrogen bubbles. Because the chemistry of the lakes changes with the seasons, the liquid can suddenly become effervescent. Imagine a giant bottle of soda being opened. Billions of tiny nitrogen bubbles rise from the depths, clumping together on the surface to create a temporary, floating froth. This froth is buoyant enough to reflect radar, making it look like a solid island until the bubbles finally pop and the island disappears back into the obsidian depths. Notice how the temperature affects the very textures of the world. At -179 degrees Celsius, materials behave in ways that defy our everyday experience. Water ice on Titan is so cold that it has the physical properties of silicate rock or granite on Earth. If you were to strike a mountain on Titan, it wouldn't feel like ice. It would feel like the hardest stone imaginable. Conversely, the liquid methane has a very low surface tension, about 1/3 that of water. This means if you were to dip your hand into the sea, the liquid would feel incredibly thin. It wouldn't cling to your skin or form large droplets like water does. It would flow away instantly, like a very light alcohol or a thin cleaning fluid, leaving you feeling strangely dry even as you touch the liquid. Deep within the center of Kraken Mare, the largest of the seas, the depth exceeds 300 meters. That is nearly 1,000 feet of liquid methane. At these depths, the pressure of the liquid itself begins to change its properties. The nitrogen that is dissolved in the methane stays trapped by the weight of the liquid above it. It is a dark, silent, and incredibly stable environment. There are no currents, no light, and no sound. It is a reservoir of perfect stillness, a place where the molecules move so slowly they are almost at rest. This sea is a giant battery of chemical energy, a quiet storehouse of the building blocks of the universe, waiting through the long, slow Titanian years. Everything on this moon is interconnected through a cycle that mirrors our own, yet operates on a completely different chemical scale. The methane evaporates, forms large drop clouds, rains down as slow-moving feathers, carves canyons into the ice rock, and settles into mirrors of liquid obsidian. This cycle has been repeating for billions of years, long before the first life appeared on Earth, and likely long after our own oceans have changed. It is a testament to the persistence of nature's patterns. Even in the deepest cold of the outer solar system, the same rhythms of evaporation and precipitation, of erosion and accumulation, continue to play out. As you observe this, you might feel a sense of your own rhythms slowing down. The heartbeat of Titan is a slow, steady pulse that doesn't care about the passage of hours. It operates in decades. It breathes in millennia. Let your own internal clock align with this planetary pace. There is no need for haste. The methane will continue to fall. The nitrogen bubbles will continue to rise, and the ice mountains will continue to stand their silent watch. You are merely a guest in this slow-motion world, a quiet presence in a landscape that defines the very meaning of peace. Every breath you take is a reminder of the thick, supportive atmosphere that surrounds you, a heavy blanket of nitrogen that keeps this world safe and still. You are ready to move deeper into the heart of this moon, to understand the relationship between the great seas and the tiny grains of organic dust that cover the plains. But for now, just feel the low gravity pulling at you with a gentle, barely there touch, and listen to the silence of the marble-sized rain. Experience the sensation of the ground beneath you as something more than just a surface. On Titan, the very soil is a library of cosmic history, composed of complex organic molecules that have been drifting down from the sky for billions of years. What's compelling is the sheer scale of this organic wealth. Scientists have calculated that Titan possesses over 100 times more liquid hydrocarbons, the building blocks of everything from plastics to the energy that powers our homes, than all the known oil and gas reserves on Earth combined. Imagine a world where the gold is not a metal, but the very substance of the lakes and the dunes. A vast reservoir of carbon-rich material waiting in a state of perfect frozen preservation. Take a moment to realize that when you look at the orange horizon of this moon, you are looking into a mirror of our own distant past. Astronomers often describe Titan as a time capsule of the prebiotic Earth. 4 billion years ago, before the first single-celled organisms appeared in our oceans, Earth likely had an atmosphere very similar to the one you are breathing now on Titan, thick, nitrogen-rich, and filled with a hazy mix of methane. By observing the slow chemical reactions in these methane lakes, we are essentially watching a slow-motion rehearsal for the beginning of life. There is a profound, personal connection in this. The carbon atoms that make up the cells of your body, the nitrogen in your DNA, are the same elements currently swirling in the dark, obsidian depths of Kraken Mare. Consider the possibility of a different kind of biology altogether, one that doesn't rely on water. On Earth, water is the universal solvent, the medium that allows the chemistry of life to occur. But at these temperatures, water is as solid as granite. Scientists have theorized that life could exist on Titan using liquid methane as its solvent. They have even modeled a hypothetical cell membrane called an azotosome, made of nitrogen, carbon, and hydrogen molecules. These structures would be stable and flexible in liquid methane at -179 degrees. Picture a microscopic world of tiny, resilient structures thriving in the deep chill of a methane pond, moving with a metabolic pace so slow it would look like stillness to our eyes. At this very moment, something subtle is happening to the ground beneath you. Titan does not have a moon of its own. but it is constantly being tugged by the immense gravity of Saturn. As Titan orbits the ringed planet every 16 Earth days, the gravitational pull causes the Moon's crust to flex and bulge. Scientists discovered that the surface of Titan can rise and fall by as much as 10 meters, about 30 feet, during each orbit. This isn't a violent movement. It is a slow, rhythmic stretching of the Moon's icy shell. Imagine the entire landscape beneath you gently inhaling and exhaling, a planetary-scale breath that moves the very mountains and seas with the patient timing of the cosmos. What's truly extraordinary is the source of energy that these hypothetical organisms might use. On the surface of Titan, there is an abundance of a molecule called acetylene. On Earth, we use acetylene in welding torches because it releases a tremendous amount of energy when reacted. On Titan, this molecule settles out of the atmosphere and dissolves into the lakes. To a methane-based organism, acetylene wouldn't be a fuel for a torch, but a source of food, a high-energy snack that could sustain life in the absence of sunlight. Picture the seabed of these lakes as a vast, dark banquet of energy, a chemical feast provided by the sun's distant rays, acting on the atmosphere far above. Notice how the landscape changes as your gaze moves toward the equator. Here, the lakes give way to the immense dune fields of Belet and Shangri-La. These dunes are not made of the silicate sand you find in the Sahara. Instead, they are composed of grains of tholin, complex organic solids that look like dark coffee grounds or charcoal. Scientists have observed that these dunes can be over 100 meters high and hundreds of kilometers long. Because the gravity is so low, the sand is incredibly light. If you were to pick up a handful, it would feel like holding a cloud of soot, barely resting in your palm before the thick wind carries it away in a slow, dark ribbon across the plains. Scientists discovered a fascinating detail about these dunes. They always point in the same direction, molded by the steady tidal winds of the atmosphere. Even though the winds on Titan are generally gentle, seldom moving faster than a few miles per hour, the air is so heavy that it exerts a significant force. It's like the steady, relentless pressure of a deep-sea current, slowly marching billions of tons of organic dust across the Moon's midsection. This process is so orderly and slow that the dunes look like a giant, frozen record of the Moon's atmospheric history, a landscape-sized graph of the winds that have blown for millions of years. At this point in our journey, we should consider the sheer longevity of this world. Titan is tidally locked to Saturn, meaning the same side always faces the planet, much like our Moon faces Earth. This creates a permanent, unchanging relationship between the two worlds. One day on Titan lasts nearly 16 Earth days, 8 days of soft, copper-toned light followed by 8 days of deep, velvet darkness. During the long night, the only light comes from the Saturn shine, the sunlight reflected off the clouds and rings of the giant planet. It is a dim, ethereal glow that turns the methane lakes into silver mirrors, a world of shadows and soft, reflected radiance that lasts for an entire week of our time. Deep within the southern hemisphere, the geography shifts again. While the north is dominated by the Great Seas, the south is home to smaller, more isolated lakes like Ontario Lacus. Scientists have found that the liquid in these southern lakes is richer in ethane, which is less volatile than methane. This creates a different texture to the water. It is thicker, more like a light oil. The shorelines here are remarkably flat, with slopes so gentle that a decrease in the lake's depth of just 1 meter could cause the shoreline to retreat by several kilometers. Picture a beach that expands and contracts with the seasons, a slow-motion tide that moves across miles of flat, dark mud over the course of several Earth years. What's happening now in the upper atmosphere is a process of constant creation. The VIMS instrument, the Visual and Infrared Mapping Spectrometer on the Cassini spacecraft, revealed that Titan's haze isn't just a random fog. It is organized into distinct layers, including a detached haze layer about 500 kilometers above the surface. This high-altitude factory is where the sun's energy breaks down methane to create the seeds of the dunes and the nutrients of the lakes. It is a continuous rain of complex matter, a literal falling of the sky that has been building the surface of this moon, grain by grain, for billions of years. There is a calming realization in the fact that this moon is a closed system. The methane that evaporates from the lakes eventually returns as rain, and the organic solids that form in the sky eventually sink into the seas or form the dunes. Nothing is lost. It is a perfect, self-sustaining loop of chemistry and weather, operating in a silence so profound it makes our own world seem loud and frantic. You are standing in a place where the concept of waste doesn't exist. Every molecule is part of a grand, circular dance that has no beginning and no end. As you allow your awareness to rest on this macroscopic view, you might feel the connection between the vastness of the Saturnian system and the tiny, organic grains beneath your feet. The same laws of physics that govern the rings of Saturn also govern the way a raindrop falls on Titan, or the way the methane ripples in a light breeze. Everything is part of a single, unified expression of nature. The cold isn't an enemy here. It is a preserver, a force that holds the world in a state of grace, preventing the chaotic, rapid changes that define our warmer home. Surrender to the weight of this stillness. The thick air holds you, the low gravity lightens you, and the slow heartbeat of the moon's crust provides a steady, rhythmic foundation for your rest. You are witnessing the bigger picture, the way a world can be a cradle for the building blocks of life without ever needing to rush toward a destination. Titan is content to simply be. It is a world of potential, a laboratory of the infinite, and a sanctuary of orange mists and obsidian waters. As we move toward the final stages of our journey, hold on to this feeling of being part of a larger, slower, and incredibly beautiful story. You are a carbon-based being on a carbon-based world, sharing a history that stretches back to the very dawn of the solar system. Breathe in that ancient nitrogen, feel the support of the dense air, and let the unhurried grace of the methane lakes become your own. Consider the way sound moves through this heavy, nitrogen-rich environment. If you were to hum a low note here, the sound would behave quite differently than it does in the thin, light air of Earth. Because the atmosphere of Titan is 4 times denser, but the temperature is so much lower, the speed of sound is significantly reduced. On Earth, sound travels at about 340 meters per second. But here, it lumbers along at just 194 meters per second. This means the acoustics of this moon are deep, resonant, and strangely delayed. Something. This is entally tense of this. This is entally. 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 This is entally tense of this. This is entally. This is entally tense. Imagine the echoes of a distant methane waterfall, which scientists have detected through radar imaging, reaching your ears as a slow, bass-heavy rumble, like the sound of a distant cello played in a cavernous, velvet-lined hall. What's happening now within the liquid of the seas is a subtle chemical sorting process. Scientists discovered that the dielectric constant of liquid methane is incredibly low, about 1.7 compared to the 80 of liquid water on Earth. This is a scientific way of saying that the liquid in these lakes is a near-perfect electrical insulator. It doesn't allow electricity to flow through it. Picture a sea that is essentially a vast, dark pool of liquid insulation, so clear and non-reactive that radio waves pass through it like light through a window. This purity is what allowed the Cassini spacecraft to map the seafloors of Ligeia Mare with such precision, revealing a bottom made of solid water ice, smoothed by the slow, cold currents of the northern summer. At this very moment, your skin might sense the methane humidity of the air. Just as Earth has a relative humidity based on water vapor, Titan has a methane cycle that keeps the lower atmosphere moist with gaseous hydrocarbons. Near the surface, the relative humidity of methane is approximately 45%. This isn't the sticky, heavy humidity of a tropical jungle. Instead, it feels like a crisp, cool mist that is constantly on the verge of turning into a gentle drizzle. This humidity is what feeds the dampness scientists observed when the Huygens probe landed, a world where the air is constantly feeding the soil and the soil is constantly feeding the air. Scientists discovered a peculiar mountain range near the equator called Sotra Patera, which includes a peak known as Doom Mons, rising 1,450 meters into the orange sky. This isn't a mountain formed by tectonic plates crashing together, but rather a cryovolcano, a volcano that spews ice instead of fire. Deep within Titan, tidal heating from Saturn's gravity creates a warm, slushy mix of water and ammonia. Every few thousand years, this cool lava erupts, flowing across the surface like thick, freezing frosting. What's noteworthy is that as this slush meets the methane atmosphere, it solidifies into a rock-hard ice that is as durable as basalt. It's a planetary-scale plumbing system, where the internal heat of the moon is slowly traded for the cold of space, building the landscape in a quiet, glacial rhythm. Picture the chemistry of the haze itself, which scientists call tholins. These are not simple dust particles. They are complex organic polymers formed from nitrogen and methane. In the upper atmosphere, about 1,000 kilometers up, sunlight breaks these molecules apart, and as they fall, they act as condensation nuclei. This means that every raindrop that falls on Titan forms around a tiny, microscopic speck of organic soot. It's a process where the sky literally builds the rain, grain by grain. By the time a methane drop reaches the lake, it is a complex chemical package, carrying the building blocks of organic complexity from the edge of space down into the obsidian depths. Notice the texture of the liquid as it interacts with your fingertips in this thought experiment. Methane has a very low viscosity, about 1/3 that of water. If you were to stir a pool of it, you would feel almost no resistance. It would feel thinner than any liquid you've ever touched, almost like a ghost of a fluid. This low viscosity, combined with the low gravity, means that ripples on the surface move with a slow, hypnotic fluidity. A single touch to the surface of Kraken Mare would send a ripple moving outward that stays perfectly formed for a much longer time than it would on Earth. Because there is less internal friction in the liquid to stop it. Consider the thermal inertia of the landscape. Because the ground is made of different materials, water ice in the mountains and organic soot in the dunes, they hold onto the sun's meager heat differently. During the 8-day-long Titanian day, the dark dunes absorb the faint sunlight and warm up slightly more than the bright, icy hills. Scientists have used infrared sensors to measure these tiny temperature differences, which are often only a few degrees. This creates very gentle, predictable thermal breezes that blow from the ice toward the dunes every evening. It is a world that operates on a delicate thermal balance, a soft breathing of the atmosphere as it moves from the cold ice to the slightly less cold sand. At this point in our journey, we should explore the peculiar light of Titan more deeply. Because the atmosphere is so thick and the sun is so far away, there is no direct sunlight on the surface. Everything is lit by skylight, the light that has been scattered millions of times by the nitrogen and methane molecules. This means the light comes from every direction at once. There are no shadows under the rocks, no dark side of the dunes. It is a world of total, soft immersion, where the light wraps around you like a warm, copper-colored blanket. It is the visual equivalent of a soft, steady hum, a light that asks nothing of your eyes and allows your vision to rest in a state of perpetual golden twilight. Scientists discovered that the lake Ligeia Mare is remarkably pure. While some lakes on Titan are rich in ethane, a heavier hydrocarbon, Ligeia Mare is almost entirely liquid methane. This purity suggests that the lake is fed primarily by direct rainfall rather than underground springs. Think of it as a giant, planetary-scale rain barrel, thousands of square miles of pure, liquid gas that has been collected over centuries of slow, rhythmic storms. The lack of impurities means the liquid is incredibly transparent. If you were to look down from a boat made of ice, you could see the hills and valleys of the seafloor hundreds of feet below, illuminated by that omnidirectional, golden glow. What's happening now in the atmosphere is the formation of polar hoods. As the seasons slowly turn over their 7-year cycles, a massive cloud of hydrogen cyanide and other complex gases forms over the winter pole. Scientists have observed these hoods using the Composite Infrared Spectrometer (CIRS) on the Cassini spacecraft. These clouds are not white like Earth's clouds. They are a deep, bruised purple and gold, swirling in a slow-motion vortex that caps the moon like a crown. As the season changes to spring, this hood slowly dissipates, raining its complex chemicals down into the lakes and replenishing the moon's organic reserves. It is a seasonal ritual that has occurred billions of times, a majestic, colorful transition that marks the passage of the long Titanian years. If you were to sample the air, you would find a trace amount of molecular hydrogen. Scientists have noticed a curious phenomenon where hydrogen seems to disappear as it reaches the surface of Titan. One compelling theory is that this hydrogen is being consumed by those hypothetical, coal-dwelling organisms we discussed earlier, who might use it to react with acetylene for energy. While we haven't found life yet, the disappearing hydrogen remains one of the most intriguing mysteries of the moon. It suggests a surface that is chemically active, a world that is not just a dead rock in space, but a place where energy is constantly being exchanged and transformed in the deep, silent chill. Think of the way the moon's gravity, only 1.35 meters per second squared, affects your sensation of weight. If you were to jump on Titan, you would rise slowly and descend even more slowly, as if you were moving through a dream. This low gravity, combined with the dense air, means that the landscape is incredibly stable. A pile of organic sand can be stacked at a much steeper angle than on Earth without collapsing. The ice mountains can reach heights that would be impossible on a larger planet. Everything is taller, steeper, and more delicate. It is a world of fragile, towering beauty, held together by the gentle grip of a small moon and the heavy embrace of a thick sky. Surrender to the scientific wonder of this place. This is not a world of chaos, but a world of extreme, quiet order. Every raindrop, every ripple, and every cryovolcanic eruption follows a set of laws that we are only just beginning to understand. The methane lakes are not just bodies of liquid, they are the heart of a planetary system that mirrors our own in ways that are both alien and familiar. You are resting on the shores of a world that is a masterpiece of organic chemistry, a silent, copper-colored sanctuary in the outer solar system. As we prepare to transition into our final stage, let these facts settle into your mind like the organic soot settling onto the dunes. The speed of sound, the purity of the methane, the height of the ice volcanoes, they are all part of a grand, stable reality. There is a deep comfort in the predictability of these laws. The universe is a place of patterns and cycles, and you are currently attuned to the slowest, most peaceful cycle of all. Let the resonance of the Titanian atmosphere fill you, the low gravity lift you, and the golden, shadowless light soothe you. You are part of the cosmos, and the cosmos is a place of profound, enduring rest. Breathe in the nitrogen, feel the thin, cool touch of the methane mist, and prepare to let the rhythms of this distant moon guide you into a state of total, unshakable sleep. As the golden tangerine light of Titan begins to soften, we find a final place of rest on the high banks of Punga Mare, one of the three great northern seas. From this vantage point, you can watch the slow-motion unfolding of a world that is preparing for its own long, quiet night. There is a specific, step-by-step process to how this world settles into its rhythms, and as we observe it, you may feel your own body following a similar sequence of release and relaxation. What is occurring right now is the slow evaporation of liquid methane from the sea's surface. On Earth, we are used to water evaporating quickly in the heat of the sun. But on Titan, this process is incredibly patient. Scientists have calculated that the evaporation rate from these lakes is only about 1 meter of liquid per year. Think of that. The surface of this massive sea lowers by a mere fraction of a millimeter every day. It is a process of such incredible gradualness that it feels less like a change and more like a state of being. Step by step, the molecules of methane detach from the liquid obsidian of the lake, rising upward into the thick nitrogen air, contributing to the soft, protective humidity that wraps around the entire moon. Notice how the temperature remains perfectly constant. When the Huygens probe touched down in 2005, its instruments recorded a surface temperature of exactly -179.16 degrees Celsius. This cold is not a biting seasonal chill. It is the fundamental foundation of the world. It is a temperature that creates a profound stillness, where chemical reactions happen with a measured, deliberate pace. Because there is no internal heat to cause turbulence, the atmosphere near the surface is incredibly calm. Scientists have measured surface wind speeds on Titan at frequently less than 1 meter per second. This is a movement so gentle you would barely feel it against your cheek. A slow, rhythmic brushing of the air that carries no dust and makes no sound. Consider the process of how the clouds form in the upper atmosphere. High above us, nearly 500 kilometers up, the sun's distant ultraviolet rays strike the methane molecules. The first step is the breaking of carbon-hydrogen bonds. Next, these fragments recombine into heavier, more complex chains. Gradually, over months and years, these chains grow larger and heavier, forming the tholin particles that give the moon its signature glow. Finally, these microscopic particles begin their long journey downward. It takes a single tholin particle several Earth years to drift from the edge of space to the surface of the moon. Imagine a snowfall where each flake takes years to reach the ground. This is the pace of Titan. It is a world that operates on a timescale so vast, it makes the frantic movements of our lives feel like a momentary flicker. As these particles descend, they eventually reach the lower atmosphere, where the pressure is 1.45 times higher than Earth's sea level. At this pressure, the air feels substantial, almost like a physical presence. It is a heavy, supportive blanket that presses gently against the landscape. Imagine your own body being supported by this dense, nitrogen-rich air. It takes the weight off your muscles and joints, allowing you to sink into the ground with a sense of total security. You are not just lying on the surface, you are being cradled by the very atmosphere of the moon. Deep within the sea of Pungamare, the liquid is remarkably still. Scientists using the VIMS instrument, the visual and infrared mapping spectrometer, discovered that the composition of these northern seas is roughly 75% liquid methane, 24% liquid ethane, and 1% nitrogen. This specific mixture creates a liquid that is as clear as high mountain air. Below the surface, the process of sedimentation is taking place. Over centuries, fine organic dust settles onto the seafloor, which radar soundings have shown to be roughly 160 meters deep in the central basins. This sediment builds up millimeter by millimeter, creating a soft, velvety floor that has never been touched by a current or a storm. Notice how your breathing is beginning to align with the orbital rhythm of the moon. Titan orbits Saturn once every 15 days and 22 hours. This is a long, slow circle that keeps the same face of the moon turned toward the planet at all times. As Titan moves through its orbit, the immense gravitational pull of Saturn causes the moon's icy crust to flex. This tidal flexing is a gradual process. The ground beneath us rises and falls by up to 10 meters over the course of those 16 days. It is a planetary heartbeat, a slow-motion inhalation and exhalation of the crust itself. Feel the ground beneath you as a living, breathing entity, moving with a rhythm that is far too slow for the conscious mind to track, but which your body can feel as a deep, resonant stability. In the sky above, the sun is a small, brilliant point, only about 1/10 the diameter of how it appears from Earth. Because of the vast distance, nearly 1.4 billion kilometers, the sunlight has been traveling for over 80 minutes before it reaches this world. By the time it passes through the thick tholin haze, the light has been filtered and softened, stripped of all its harshness. It is a light that has been refined by its journey through the cosmos, arriving here as a gentle, copper radiance. This light does not demand your attention, it simply exists, illuminating the mountains of ice and the plains of organic silt with a soft, unwavering glow. As we bring our observation to a close, consider the way the methane cycle mirrors the process of entering sleep. First, there is the rising, the evaporation of the day's thoughts, becoming lighter and more ethereal. Then, there is the drift, the long, slow descent through the quiet layers of the mind, like tholin particles falling through a nitrogen sky. Finally, there is the settling the moment the thoughts reach the still, dark surface of the deep mind, merging with the obsidian waters of rest. The moon of Titan is now entering a period of deep seasonal transition. A single year on Titan lasts 29.45 Earth years. For the next 7 years, the northern hemisphere, where we rest, will remain in a state of quiet, sun-drenched summer, followed by a winter that will last for nearly a decade. This is a world that understands the necessity of long, deep rest. It does not rush through its seasons. It honors the time required for the cold to deepen and for the atmosphere to settle. Let the weight of the Titanian atmosphere press down on your limbs anchoring you to this place of perfect peace. The gravity is light, the air is thick, and the world is silent. There is nothing left to observe, nothing left to understand. The facts of the moon are now part of your own inner landscape. The 160-meter depths, the -179-degree chill, the years-long descent of the golden dust, all of these are now anchors for your own tranquility. As the image of the methane lakes begins to fade, replaced by the soft, dark warmth of your own rest, carry these affirmations with you into the silence. My body is as light as a feather in the titanian gravity. My mind is as clear as the methane in léger amer. My breath is as slow and steady as the tidal flexing of the moon. I am supported by a dense, protective atmosphere of calm. The cold of the world outside only deepens the warmth of my rest. I am moving through a slow-motion descent toward perfect stillness. The rhythms of the cosmos are my own rhythms. I am a part of a stable, orderly, and beautiful universe. Each breath takes me deeper into the copper-toned twilight of sleep. I am resting on the bedrock of ancient, diamond-hard ice. The golden dust of the sky is settling over my thoughts, bringing peace. I am sinking into the velvet depths of a silent, obsidian sea. The long seasons of the stars are guiding me toward home. There is no rush, only the patient passage of cosmic time. I am safe. I am still. I am at rest. The lakes are silent now. The ripples have smoothed into a perfect mirror. The orange haze has become a soft, dark velvet. Saturn hangs in the sky, a silent guardian of your sleep. The journey is complete, and the world of methane and ice is now a part of your dreams. Good night.